Hi folks, this is Karim Raouf from IT Visualizer channel. We'll continue our lab matrix labs, the video number 140. We have been discussing in the previous video the following. While still working with troubleshooting Windows using Microsoft Sysinternals suite, we have a lot of cases concerning this topic, and we have stopped the last time at case number 36. We should discuss it today, the process killing malware. All of these cases are a learning dialogue between a senior IT and the junior IT. Leo is the senior IT, Maya is the junior IT. So let's see how they solve issues by using the sysinternal suite. So let's see. Leo, this case involved malware that displayed a message claiming the computer was infected and demanding payment to clean it. Another fake antivirus scam. We have seen this in the previous case. This is called scareware. Okay, yes, but this one was particularly aggressive. It prevented any new process from running. The other one was just popping up some messages saying that your computer is infected and you need to purchase a fake software to clean your PC. But it didn't stop any processes. So this is an aggressive one. It prevented any new process from running, including command prompt, PowerShell, task manager, and even sysinternal tools. So we have seen this, how this can be solved using desktop or using another virtual desktop or using desktops utility in sysinternal suite. I think we have seen this before. If it blocked all tools, how did they remove it? They tried using desktop like in the previous case. We have seen this in the previous case, but the malware blocked that too. So this is another thing. What if it blocks this one and the desktop's software? So they boot it into safe mode with command prompt, which shows minimal drivers and auto starts. Okay, I think this is another thing we can use. If it fails from the normal mode, we can boot into safe mode. In safe mode with command prompt, they run auto run. We know what is the auto run. In auto run, they found numerous suspicious items, including file sharing programs and browser extensions, but the main culprit, it was an entry with no description or publisher, a random named this name launching from HKCU, this is a registry key, run once key. So they got into safe mode, run the auto runs, and they found this suspicious automatic or suspicious entry in the registry that runs, I think, a certain program once automatically when the PC boots. They show the malicious auto run entry, so they could remove it from the safe mode because it auto starts mechanism wasn't being processed exactly. They deleted the entry in the auto run and removed its file, then started normally. Okay, what's interesting is that this malware didn't need administrative rights to cause such damage. That's an important point. While malware with administrative rights can do more damage to the system itself, even user level malware can completely ruin the user experience. That's why running with standard user rights does not eliminate the need for good security practices. Okay, so this is another case which seems to be a simple one. Then we have the case number 37, the fake system component. This case involves malware uh, masquerading as a critical Windows component. The admin noticed two instances of csrss.exe running under one user session, which is abnormal. What is this file? In the client server runtime subsystem, a critical Windows component that should only have one instance per session, having two is definitely suspicious. So it's CRSS, it's the client server runtime subsystem. I don't know what this does exactly, but we can ask AI tools to clarify what does it do exactly. So he says that this should have only one instant running per user, so you should not have more than one. Okay, one instant per session, I think maybe per user or per user session. Okay, so how did they investigate? The task manager doesn't show the full path of executables, but the process explorer does. Hovering over the suspicious CRS process revealed it's running from WinDire instead of WinDire System 32. WinDiarine mirrors C Windows. It runs from C Windows. It should, or its original location should be in C Windows System 32. So this is a fake file or a copy that seems to be running from a different location. They examine the Process Explorer tool tip showing the suspicious path. Next, they use the strings utility to examine the content of the fake CSRSS. This is another utility called strings that will get any instructions or any hidden instructions in an exe file. Strings reveal code for creating autorun.inf files to copy two removable drivers, enumerating computers and file shares, and copying the malware with misleading file names. So it reveals the code. Strings, it can reveal hidden instructions or text instructions, or it can reveal the code. And in the code, or the XE, they see that there is this file creates an autorun.inf file to copy this to be copied to removable devices and computers and file shares, and copying the malware with misleading file names. So creating autorun files to copy to removable drives, enumerating computers and file shares, and copying the malware with misleading file names. So this is an autorun.inf that I think it will be copied to removable devices or shares, and it will then do a copy of this crs.exe file and copy it to other computers. So it was designed to spread through USB and network shares. Yes, this was the Win32 Visual.b worm. The strings utility quickly revealed its malicious capabilities without needing to execute it. Process Explorer made it easy to spot the fake system component, and a string revealed exactly what it was doing. These tools give you a quick, safe way to analyze suspicious file without realized was specialized reverse engineering skills. It's like being able to read a book content without opening it. We have seen strings before, and we have seen the Process Explorer. Let me first try to ask a question to AI tools. Let it very very simple. For example, let's go to Perplexity, and then we can do like this. Explain in simple terms. Let's see if this we explain in layman terms. Let's see, this will be as simple as it can, and let's see this. Okay, this is client server runtime subsystem. It is a critical system process in Microsoft Windows operating system that runs in the background to help the system function properly. In simple terms, it's like a helper program that manages important parts of how Windows works, especially related to graphical interface and command line windows. So this is a critical process. What does it do? Manage graphical elements and console windows. It helps create and control Windows menus, dialog box, and the command prompt console window that you use to interact with the system. Very, very critical system or system component. Handles processes and thread management. It assists in starting and stopping programs and their smaller parts, threads, which is essential for running applications smoothly. Acts as a communication bridge. It facilitates communication between user application and the core part of Windows called the kernel, ensuring commands and requests are properly handled without risking system cap. So this is a very, very critical system component. Support system shutdown and session management. It helps the user. It helps manage user sessions and the orderly shutdown of the system. Why it is important? It's classified as critical system process. If it stops working or it is terminated, Windows will likely crash or become unusable because many essential functions depend on it. It runs multiple instances uh, on a system to support different user sessions, especially in multi-user environment. But there is only one session per user or one file per user session. Is CRC safe? The genuine CRC is safe and essential part of Windows, usually located in this location. However, because it's so important, some malware tries to disguise itself with the name so and so to avoid detection. It's important to keep antivirus software updated and scan your system regularly to ensure the process running is legitimate. So this is very, very good. Now we can ask it another question. What is uh, the virus called this one. So this is the virus. What is explain in layman terms? So let's see this. They have a computer worm, a malicious program that spreads itself automatically to other computers, mainly through email and network connections. In simple terms, it's a harmful software that tries to infect as many computers as possible by sending copies of itself via email messages and share network drivers, even through USB. How this is work, it often arrives disguised in an email with subject like here you have and include a link that looks like a PDF but actually downloads a harmful program when clicked. Once a computer Once on a computer, the worm downloads other programs, including tools that can recover saved passwords from browsers and email clients. It tries to spread itself to other computers by copying itself to shared folders on the network and using administrator credentials if available. It creates a shared folder named updates on the infected computer to help spread the infection further. Infected computer. The worm modifies system files and settings to block antivirus and security software from updating or running properly, make it harder to detect and remove. It disables the Windows firewall and security services to weaken the computer defenses. It can send stolen information like recovered password to hardcore email addresses. It attempts to copy itself to other computers on the same network or to the removable drivers like USB stick using auto-run feature to infect new machines automatically. The worm installs a backdoor program called Frost, which lets an attacker remotely control the infected computer, browse files, run programs, capture screenshots, log keystrokes, and even control the webcam. Why it is dangerous? It spreads quickly across networks and available and removable drivers without needing user help beyond clicking the initial link. Tweaks the infect computer security, making it vulnerable to further attacks. It steals sensitive information like passwords. It gives attacker remote control over the infected computer, which can be used for spying, stealing data, or launching attacks on other systems. How to protect yourself? We can see avoid suspicious links, keep antivirus up to date, restrict permissions on shared network folders, disable autorun feature. This is a good practice. GPO to disable autorun on any devices, USBs or DVDs. Apply all Windows security updates and patches. So this seems to be a good one. If we go to the case number 38, the Leo, in this final malware case, a hospital network was hit by a virus that caused printers to receive huge printer jobs of garbage text. So this is another case, as we can see here, very dangerous one. The explanation of cloud seems to be a little bit complicated. I actually asked Grok to explain the case. So here is the case explained by Grok. I try to read it loudly. Imagine a big hospital where there are all printers suddenly spitting out pages and pages of nonsense text. Uh, it was a mess, wasting paper and driving everyone crazy. The tech team figured out it was caused by a sneaky virus called Mario Ever virus. They found a bad file named MarioEver.exe on the computers, but here is the tricky part. Every time they delete it and restart the computer, it popped up back up. It was like a bombarding that wouldn't stay away. The team dug deeper and found another suspicious file, a DLL file. Think of it as a helper file that program uses called nvrsma.dll. Okay, so they find a file that was in C Windows folder, something called nvrsma.dll. If we go there and see the file is saying that was uh, in uh, not in C Windows, C Windows System 32. So they found this DLL in C Windows System 32, and they try to know who already downloaded this file or what program is using this DLL file. So they found WinLogin, which is a very, very critical process in Windows related to login of users and so let's continue here. This is a file was sitting in a special folder where imported Windows file live, see Windows System 32, but it didn't belong there. The computer didn't even have NVIDIA graphic card. So this seems to be related to NVIDIA or try to imitate itself or to disguise as NVIDIA driver, which might have explained it. When they tried to delete this DLL file, the computer said nope, something using it. So they used the tool called list DLL. This is what we are talking about, one of the tools of Sysinternal suite. They see this DLL file is used by this process, and this was the output. Okay, so what happens like after that sprite? It was WinLogin, a super important part of Windows that helps you log in and log out. Now, why was Windows login using this weird DLL? They checked with another tool called Autoruns, which shows everything that start up automatically with Windows, but nothing found about this DLL file. So it's not loaded out automatically when the user login. It was a dead end. So they turned to Process Monitor, a tool that acts like a detective notebook, recording everything the computer does. Even while it's starting up, they set it up to watch the computer boot up. So they use the process monitor to log in the boot process. So maybe the file is loaded during the boot process, not the login process of the user. So they open a certain option in process monitor to monitor the boot process and record it. Okay. They set it to watch the computer boot up, and after rebooting, they searched the records of NVRSMA. Bingo, they saw that WinLogin was reading a setting in the registry, a big storage space for Windows setting called DZZ-blend.dll, and then loading this DLL file. So what happened that the WinLogin goes to the registry and read a certain registry key. In this registry key is telling it to download this DLL file. So this is the case. If we go to okay, I think no, we don't need to do that, or don't need to put to see this. So what happens here that this file or this registry loads this DLL file. So this was odd because there is a normal setting called app into DLL. So there is another registry key which name is very, very similar to this one, but what seems to be done that they changed app to DZ. So they renamed this file to another file. So that was because there was a normal setting called DLL that tells Windows to load helper files into program. But this is strange. It's not a thing unless something sneaky made it up. They looked at the call stack, a list showing how the computer got to that point. So you're trying to see how this DLL file was loaded. Okay, they see the WinLogin stack. So what they do, they see the call stack or how the WinLogin has loaded this DLL file by tracing up the processes. They have seen that and saw that a file called user32.dll was involved. So this DLL file loaded this file. So the Windows login goes to the registry, and the registry loads this DLL file. In the process, okay, this also DLL file is involved. So user32 is a legitimate Windows file that helps the things like Windows and buttons on your screen. But when they check it on the affected computer, it had been changes. It had last modified date matched when the virus hit, and it didn't pass a security check that proves it's the real Microsoft file. So what happened here that in a certain way uh, one of the files of the system was modified, okay, and played with to download this DLL file, okay, and this also after modifying it, its signature was not its signature is not from Microsoft. It appears to be not or it was tampered with. The signature is just to make sure that it is from Microsoft and is not tampered with. At the time it was changed, then the signature was disappeared or it was broken. Okay, so here the compared what they done, they compared the infected DLL file to a clean one from a good computer. Inside these files are bits of text called strings, and they found the differences. The clean file had this app DLL, but the infected one is so we can deduct from that or know from that that this user file, okay, calls this registry key, and this registry key downloads or opens the DLL file. So which seems to be in steps. We can see that I think when login uh, calls this registry key, and this registry key called this one, and uh, I think maybe when login, okay, let's see that. When login will talk to this DLL file, which will talk to this registry key and download another file. Because this seems to be related, this is Win login and this is Win32, and they are related to windows and buttons on your screen. So I think Win login and user 32 DLL is related somehow. Okay, so anyway, this is the process. Finally, we see that the whole problem was in this file. It was modified. So when the win login calls this file calls this one instead of the original one, which is app into DLL, and then it will call nvrsma.dll. So this seems to be the case. Okay, but the infected ones of the virus tweaked two letters in user32.dll. So we have changed the strings in this DLL file to trick Windows into looking at different setting one the virus control. This let the virus load its DLL every time the computer started, keeping the malware alive. So he didn't put an auto login mechanism, but he just played as one of the DLL files that appears legitimate for the Windows, and then it does its work. The trick was super clever because it used ASAP, a way for programs to start automatically that nobody knew about it until then. To fix it, they couldn't just replace this file while Windows was running. It was logged in use. So they started a computer special tool called WinPE, or Windows pre environment, a mini version of Windows that runs from a CD. From there, they swapped out the bad file with a clean one and deleted the viruses for good. In short, the virus was like a master magician. It changed a tiny part of an imported Windows file to make sure it could keep coming back at even after being deleted. The tech team has to use special tools and a clever workaround to finally kick it out. So this is a very clever way for a virus to do that. Let's see the explanation of ChatGPT. I give him the same one. So let's read also what this what the explanation is. Okay, so I can read out everything loudly, but let's read only the part that we need. So here is the part. Let's read it out loudly and see. Okay, here you go. And let's do it again from the beginning. Here is the story. So let's go further and go to this one, and then try to read it out loudly.
The story, without the jargon. What happened? In a big hospital, every printer suddenly started spitting out pages of random symbols. That alerted the IT team that something nasty was inside their network. First clue, antivirus pointed to a file called marioforever.exe in the Windows folder. Deleting it did nothing. Each reboot brought it back. That meant the virus had persistence tricks. Hunting for the trick, they noticed a second odd file, nersma.dll. Windows refused to delete it because a critical Windows program, WinLogon, was using it. Which program is using it? With a free Sysinternals tool called listdlls, they confirmed WinLogon had loaded nersma.dll. That's bad, because WinLogon starts very early when Windows boots, giving malware a head start. Why is Winlagon loading it? Autoruns, a tool that lists every auto start location, showed nothing. So they captured everything that happens while Windows boots with another tool, Process Monitor, in boot logging mode. Smoking gun in the registry. The boot log showed Winlagon reading a registry value called DLS, then loading nersma.dll. Windows normally reads appinit.ls, so why the strange name? The aha moment. Comparing a clean system file, user32.dll, with the infected one revealed only two changed letters. Appinit_ls had been patched to deepinit_ls. Result: Windows silently looked at a brand new registry key that only the malware knew about, keeping it hidden from normal tools. Cleaning up. Because user32.dll is locked while Windows runs, the team booted from a separate rescue disk. WinP copied a clean user32.dll over the bad one and deleted the rogue files. No more junk printouts. Why this matters in plain words. Tiny change, huge impact. Altering just 2 bytes inside a core Windows file let the virus invent a completely new auto start slot that security tools weren't watching. Right tools, right order. Free Sysinternals utilities, autoruns, list_ls, process monitor. Let the admins observe first and delete later, avoiding guess and hope fixes. Lesson learned. If malware keeps coming back, look for hidden startup methods. And don't trust that nothing shows in autoruns means you're safe.
So this is the case. Let's see Gemini again. I have given it to Gemini and ask it also to explain the same thing. So let me see here if this is also a good explanation. So this is 3 explanations from 3 different AI tools. Let's read it loudly.
Okay, let's break down the case of the mysterious ASCP in simple terms. The problem. Imagine a hospital network where suddenly all the printers start printing pages and pages of nonsense. This is causing chaos. The tech support person finds a suspicious program file named marioforever.exe. They delete it, but after restarting the computer, the file magically reappears and the printers start going crazy again. The investigation, finding the hidden trick. The virus won't stay deleted. The fact that the virus file, marioforever.exe, kept coming back meant it had a secret way of starting itself up again every time the computer booted. This is called persistence. Suspicious file. They noticed another strange file, nersma.dll, that was recently created. It looked like it belonged to NVIDIA graphics cards, but the computer didn't have one. Try to delete this file failed because some program was actively using it. Who's using the file? They used a tool, list_dlls, to see which program had nersma.dll open. The culprit was winlagon.exe. This is a very important core Windows program that runs early when Windows starts. This was bad news. The malware had hooked itself into a critical system process. How did it get there? Usually, programs that start automatically are listed in specific places in the system. They use tools, autoruns/autorunc, designed to find all these automatic startup entries. But nersma.dll wasn't listed anywhere obvious. This was puzzling. Watching the startup, since the malware started early with winlagon.exe, they used a powerful monitoring tool, Process Monitor, set up to record everything happening from the moment the computer turned on, boot logging. The aha moment. After restarting and checking the log, they found winlagon.exe doing something strange right before loading the bad nersma.dll. It was checking a weird location in the Windows settings, the registry, called _ls. This location told winlagon.exe to load nersma.dll. The twist, there's a legitimate setting location called appinit_ls that Windows sometimes uses to load helpful helper files, DLLs, into programs. The name ds.ls was suspiciously similar. Why was winlagon.exe looking for this weird, misspelled name instead of the real one? The modified clue. They investigated why winlagon.exe was looking for LLS. They traced it back to a fundamental Windows file called user32.dll. They noticed this file had been modified around the time the infection started and failed a security check. The smoking gun, comparing the text inside the modified user32.dll with a clean, original version, they found only one tiny difference. The text appended_ls in the original file had been changed to ls in the modified file. The conclusion, the mysterious ASCP explained. The malware was incredibly sneaky. Instead of just adding itself to a known list of startup programs, it actually edited a core Windows file, user32.dll. By changing just 2 letters in that file, it tricked Windows, specifically the winlagon.exe process, into looking for instructions in a new, hidden place in the settings, LLS, instead of a normal place, appended_LLS. The malware then put its own instruction in that hidden place, telling Windows to load the bad nersma.dll file. This created a brand new, hidden auto-start extensibility point, ASCP, a secret doorway for the malware to automatically start every time, which standard tools couldn't find because they were looking for the normal doorways. The fix. Because the modified user32.dll file was locked while Windows was running, they had to restart the computer using a special startup disk, WinP. From this separate environment, they could replace the hacked user32.dll with a clean copy and delete the malware files, marioforever.exe, nersma.dll, and the fake registry setting. In short, the malware didn't just hide, it slightly changed the house's blueprint, a core Windows file, so that a secret door, a hidden startup location, would work, letting the malware back in every time the computer started.
So I think now the case is clearly clarified. This is case number 38. So we can go to case 39, the Q driver. This is also seems to be uh, a little bit of a complicated case. So let me also explain it using Claude. Explain it using Grok. Okay, let's read out this case again. So the explanation of the Q case, this is another case. So let me read it out again loudly. Here you go, and try to put it in a simple way. So now here it is. This is the case. Let's try to read it loudly.
Explanation of the case of the question drive in layman's terms. Imagine you're using your computer one day, and out of the blue, you notice something odd in Windows Explorer, the place where you look at all your files and folders. There's a new drive called local disk question sitting there, like an unexpected guest. You didn't plug in a USB or install a new hard drive, so you're puzzled. Even stranger, it doesn't tell you how much space it has or what's on it. And when you try to open it, you get a big access denied message. It's as if this mystery drive is locked tight and won't let you peek inside. Naturally, you want to figure out what's going on. You start with the usual tools built into Windows to check your drives. First, you open Disk Management, which is like a map of all the storage spaces on your computer, your hard drives, partitions, and so on. But when you look, there's no question drive anywhere. Then you try DiskPart, a command line tool that's a bit more technical, but great for managing disks. Again, no sign of question. It's like this drive is a ghost, visible in Explorer, but invisible to the standard tools. So you decide to bring in some special helpers from the Sysinternals toolkit, a collection of advanced utilities that can dig deeper into Windows than the built-in options. Your first tool is DiskXT.
So this is disk xt. Here, this is the error when you try to open the Q1. Okay, and uh, when you try the utility. Okay, let's go to the utility again. This utility.
DiskXT, which is like a detective that uncovers hidden details about drives. When you run it, DiskXT finally spots the question drive. It says question isn't a normal drive. It's labeled as special and tied to something called /device /SFTVol. This is your first big clue. Question isn't a physical hard drive, but some kind of virtual or unusual storage thing. Next, you use another Sysinternals tool called WinObj, which lets you explore the behind-the-scenes structure of Windows. Think of it as a way to peek into the computer's secret filing cabinet. In WinObj, you check a folder called /global and find an entry for question along with a weird code called a GUID, a unique identifier. Both point to /device /SFTVol. Then, you look in the /device folder and see SFTVol listed there, confirming it's a real thing Windows recognizes. This trail is leading somewhere. Following the breadcrumbs, you check the /driver folder in WinObj and find a driver named full. A driver is a small program that helps Windows talk to devices, whether they're physical, like a mouse, or virtual, like this SFTVol thing. Now you're thinking this vol driver might be the key to the question drive mystery. To learn more, you dive into the Windows registry, a giant database where Windows keeps all its settings. Under HKLM /system /current control set /services /full, you find details about the svol driver, including where its file lives on your computer, probably c:\windows /system 32 /drivers /sftvol.sys. But before you celebrate, you want to make sure this isn't some sneaky malware pretending to be legit. So, you use another Sysinternals tool, SIGCheck, to inspect the driver file. SIGCheck checks the file's digital signature, a kind of security stamp that proves who made it. The result? It's signed by Microsoft, and it's called the Microsoft Application Virtualization Volume Manager, part of something called Microsoft AppV. The puzzle pieces finally click together. The question drive isn't a glitch or a virus. It's a virtual drive created by Microsoft Application Virtualization, AppV, a technology companies use to run apps in a special isolated space, like a bubble on your computer. Your company probably uses AppV to deploy software, and the question drive is part of that setup. The access denied message makes sense too. It's not meant for you to browse. It's just there to support those virtual apps. In the end, what started as a confusing mystery turned out to be a normal, if hidden, part of your system. By using a mix of Sysinternals tools, DiskXT, WinObj, and SIGCheck, you cracked the case when the standard tools couldn't help. It's like being a computer detective, piecing together clues with the right gadgets.
So this seems to be the case. For example, this is how you can check for the driver if it is signed or not with Microsoft. And this is the error that happens when he try to access the queue partition, and this is under this device, so and so. So this is the case. Let's try to see ChatGPT if it also explains it in another way, so we can comprehend more, or to uh, to see more the mystery queue. Let's try to see again. Here we go. Let's go there and let's try to read it out loudly.
Weird Drive appears an employee opened this PC and saw a brand new hard disk icon named local disk question. Oddities. Windows showed no size or free space, and double-clicking it said access denied.
So strange why it is already disappearing. Let's try to read it out loudly. So here you go, that's it.
The mystery of the question drive, told simply. Weird Drive appears an employee opened this PC and saw a brand new hard disk icon named local disk question. Oddities. Windows showed no size or free space, and double-clicking it said access denied. Regular checks show nothing. Disk management and diskpart, the built-in Windows tools that list every real disk, showed no trace of question. So it clearly wasn't an ordinary hard drive or USB stick. Digging deeper, with Sysinternals tools. Step. Tool. What it revealed. 1. DiskXT lists all volumes, even weird ones. Reported question as type equals special and linked it to /device /sftvol. 2. WinObj shows hidden OS objects. Confirmed there's a device called sftvol and a driver named svol controlling it. 3. SIGCheck verifies file publishers. Showed svol.sys is digitally signed by Microsoft and described as Microsoft Application Virtualization Volume Manager. The answer: many companies use Microsoft AppV to run programs in self-contained bubbles. AppV quietly creates a fake drive, often question, where those virtualized apps think they live. That drive is hidden from normal disk tools because it's virtual, managed entirely by the AppV driver. It's locked down, so users see access denied. Takeaway: a puzzling drive letter doesn't always mean malware. By chaining the right Sysinternals utilities, you can trace a mystery device back to a legitimate Windows feature. In this case, AppV.
So I think also the case is revealing more and more if we go and try to read the explanation of Gemini. This is the case of the Q drive.
Standard tools couldn't see it properly, but specialized tools help trace it back to its source. Glossary of terms. Okay, let's break down the case of the question drive in simple terms. The problem. Imagine you suddenly see a new drive labeled question pop up in your computer's file explorer, the window where you see your C, drive, folders, and files. But this question drive is weird. It doesn't show how big it is or how much free space it has. If you try to click on it or open it, you get an access denied error message. You didn't intentionally create or connect this drive. So the mystery is, what is this question drive and why is it there? The investigation: finding the source. Check the usual suspects. The first step was to use the standard Windows tools for managing disks. Disk management, a built-in tool that shows all the physical hard drives, partitions, and drive letters. Diskpart, a command line tool for more advanced disk management. Result: neither of these standard tools showed the question drive at all. This means it wasn't a normal hard drive partition. Bring in a specialist tool. DiskXT, since the standard tools failed, they used a special tool called DiskXT. This tool can sometimes see disk-like things that the standard tools don't list. Result: DiskXT did list the question drive. It called it a special type and showed it was linked to an internal system named /device /sftvol. This was the first real clue. The drive isn't a normal disk partition, but some kind of special device named sftvol. Explore the system's inner map. WinObj. The next step was to use another specialized tool, WinObj. Think of WinObj as a way to browse the very detailed internal map that Windows uses to keep track of all its components, like devices, drivers, drive letters, etc. Result: using WinObj, they confirmed. In the part of the map where drive letters are listed /global, question was indeed linked to /device /sftvol. In the part of the map listing devices /device, there was an actual device object named sftvol. In the part listing drivers /driver, there was a driver named svol. Find the driver's settings registry. Knowing there was a driver named svol, they looked it up in the Windows registry, the central database for system settings. They found a service entry for svol, which pointed to the actual driver file on the hard disk, likely C:\windows /system 32 /drivers /sftvol.sys. Check the driver's ID card. SIGCheck. Finally, they used a tool called SIGCheck to examine the driver file, svol.sys. SIGCheck verifies if the file is legitimate and hasn't been tampered with, and it shows information about who made it. Result: SigCheck confirmed this vol.sys file was digitally signed by Microsoft Corporation. Its description was Microsoft Application Virtualization Volume Manager. The signing date, February 2nd, 2025, also appeared legitimate given the current date, May 1st, 2025. The conclusion, mystery solved. Putting all the clues together. The question drive wasn't a real disk partition. It was linked to a special device named /device/SFTVol. This device was controlled by a driver file vol.sys. This driver was made by Microsoft and is part of their application virtualization, AppV, technology. So, the mysterious question drive was actually created intentionally by Microsoft AppV software, which was likely installed by the user's company IT department. AppV uses this virtual drive, question, as a special container for running applications without fully installing them in the traditional way. The reason it showed access denied is that users aren't normally meant to browse inside it directly. In short, the strange question drive wasn't a virus or an error, but a legitimate part of a corporate software system, Microsoft AppV, that creates a virtual drive for running applications. Standard tools couldn't see it properly, but specialized tools help trace it back to its source.
So as you can see, very, very good explanation of both AI tools. Now we can go to uh, the case of the unexplained network connections. Here is a case where a user being concerned about seeing traffic from his wife's laptop to his desktop PC every few seconds. What was causing this traffic? The user first spotted uh, in Wireshark, a network monitoring tool showing connections from his wife's laptop, this IP to his IP, approximately every 2 seconds. They examined the Wireshark capture to identify the source on his wife's laptop. He used TCP view, which shows an acknowledged TCP connection request from the system process to port 445 SMB on his PC. So there is a system process on his wife's laptop is talking to port 445 on his PC. What is SMB? Server message block. It's the protocol Windows uses for file print sharing. To determine which component of the system process was making these connections, he ran process monitor for a few minutes on his wife's laptop. Okay, using the Procmon, using the count occurrence features to quickly scan result code. We have seen the account occurrence before. He found two bad network path results. They use count occurrence in Procmon. Both events came from spool sv.exe. This is the printer spooler, which was trying to access the remote spooler name pipeline interface on his desktop PC. So his wife laptop is trying to print to a printer shared on his PC. So his wife laptop is trying to connect to a printer that is connecting to his PC, and he removed this printer. Okay, why would the printer spooler trying to connect? When he checked device and printers in the control panel of his wife's laptop, he found a printer connection that used to be on his PC. After moving it, the network traffic stopped. So the printer spooler was just checking periodically for a printer that was no longer available. Exactly what appeared suspicious at first had a completely innocent explanation. It's like hearing noise in your house at night and discovering it's just the refrigerator ice maker, not an intruder. So this is again another case solved. This case, the short-lived processes. This is again a very strange case. In this case, someone accidentally left the Procmon running for over 26 minutes and noticed many short-lived processes being launched repeatedly. Let me show you all what this case is about. If I go to Grok again to explain this case, let me go and try to put it in a simple way. Here is this case, the case of short-lived processes in layman terms. Let's try to read it out loudly and see what this case brings to us. Okay, so here you go. This is the case. Let's try to read it out loudly.
Explanation of the case of the short-lived processes in layman's terms. Imagine you're running a busy kitchen in a restaurant and every now and then it gets crazy for just a few seconds. Pots banging, ovens beeping, but by the time you walk in to check, everything's quiet again. You know something's wrong, but you can't catch it happening. That's what Jamal was dealing with on a computer server. Its brain, the CPU, was suddenly working extra hard for short bursts, but when he looked with Task Manager, a basic tool like glancing into the kitchen, everything seemed fine. Elena, his tech-savvy colleague, explained that some tasks, called processes, start and finish so fast that they're gone before you can spot them manually. It's like a mouse scurrying across the floor and hiding before you turn on the light. To catch these quick culprits, they needed a tool that could watch the server all the time, like a security camera recording every move. They turned to Process Monitor, Procmon, a super detailed tool that logs everything the computer does. Jamal let it run for 30 minutes and checked the process tree, which is like a family tree showing which programs started which others. He spotted an application called tfic.exe that kept launching two little helper tools, tasklist.exe, which lists all running programs, and find.exe, which searches for specific text every minute or two. It looked like tfic.exe was set up to check if some communication programs were running smoothly, but it was doing it in a clunky way, like hiring a new worker every minute to peek at the stove instead of having one person keep watch. The problem was these constant check-ins were stressing the server CPU. To figure out how much, they needed to measure the brain power these quick tasks were using. But there was a catch. Every process gets a number called a PID, like a temporary name tag. And when a process finishes, that number can be reused by a totally different process later. It's like if two different workers were the same name tag at different times. You might confuse them if you're not careful. To avoid this mix-up, they used a smart trick with Procmon. Besides PIDs, it gives each process a unique process index, a special ID that never gets reused during the recording. Think of it as a permanent badge that only one process can have. By tracking this process index, they could be sure they were following the right processes, tfic.exe and its helpers, no matter what. Here's how they cracked the case. Filtered the evidence. They told Procmon to focus on two things: when processes stopped, process exit events, and regular snapshots of how busy the CPU was, process profiling events. It's like zooming the security footage to when workers clock out or when someone checks how hectic the kitchen is. Save the clues. They exported this filtered info into an XML file, a format that keeps all the details organized, including those unique process index numbers. It's like saving the camera footage in a way that's easy to analyze later. Crunch the numbers with PowerShell. They use PowerShell, a tool that's like a tech wizard assistant, to dig into the XML file. They found tfic.exe and all the little processes it started, its children, using the process index. Added up the CPU time from processes that finished during the 30 minutes from process exit events. For processes still running at the end, they grabbed the latest CPU snapshot from process profiling events. Totaled it all up to see how much CPU time tfic.exe and its helpers were eating up. The result? Even though each little process didn't use much CPU on its own, launching them over and over added up to a big drain on the server's resources. It's like flicking a light switch on and off all day. Each flick uses a tiny bit of power, but do it constantly, and it's a problem. The fix was simple. Stop launching new helpers every minute. Instead, they plan to set up one steady program to monitor everything quietly in the background, like hiring a single comm chef to keep an eye on the kitchen instead of a parade of noisy temps. This case shows how tricky computer problems can hide from basic tools, and how using a combo of advanced gadgets like Procmon and clever analysis like PowerShell can uncover the truth.
So this is again the case. Let's try to read what ChatGPT said about explaining this case. So this is the blink and you miss. Let's see here the explanation again. It seems to be shorter than Grok, but let me try to read it out loudly.
S. Procmon. with scripting to crunch the blink and you miss them processes what really happened. Mysterious CPU spikes, a server kept showing momentary jumps in processor use. By the time someone opened Task Manager, the culprit had vanished. Why normal tools miss it? Many programs can start, finish their work, and disappear in less than a second. If you happen to look a few seconds later, you'll see nothing unusual. Catching the culprit. Process Monitor, Procmon, was left recording for 30 minutes. Its process tree view revealed a tiny program tfic.exe that, every minute or two, launched tasklist.exe and find.exe, then quit. Those two tools are harmless Windows command line utilities, but spawning them dozens of times an hour eat CPU. The PID reuse trap Windows recycles process ID numbers, PIDs. When tfic.exe died, Windows reused its PID for other, unrelated programs. That made Procmon's summary view look like tfic.exe had spawned mystery children that weren't really related. The advanced workaround. Procmon's raw XML log stores a hidden process index that never changes, even if a PID is recycled. Exporting a log to XML and parsing it with a PowerShell script let the team track tfic.exe and only its real descendants. Adding together CPU time from hundreds of these quick bursts showed the script consumed a surprising chunk of the server's day. Fix and lesson learned a single, always running watchdog program would do the same health checks without the constant start/stop overhead. Takeaway: short-lived processes can slip past casual checks. So combine continuous capture tools, Procmon, with scripting to crunch the data accurately.
So again, the case seems to be now revealed more and more. So now we have case number 42, the last case in uh, our things today. Uh, the app installer recorder. This is also another case. Uh, as we can see here, let me try to also explain it using Grok. Okay, because actually also it seems not to be clearly explained or explained by Claude 3.7 Sonnet. Let's read this one again and see what is the case.
Explanation of the case of the app install recorder in layman's terms. Imagine you've got an old video game you love, but it only works on an ancient computer, like one from the 90s. You want to play it on your shiny new laptop, but there's a problem. The program that sets up the game, called the installer, is so old that your new laptop doesn't even recognize it. It's like trying to use a cassette tape in a phone. No dice. But here's the catch. If you could somehow get the game installed, it would actually run fine on your new laptop because the game itself isn't that old. So, how do you make it work? That's the challenge the tech team faced in this case. They had some old software with an installer that wouldn't run on modern computers, called 64-bit systems. But once installed, the software itself would work perfectly. Their clever fix? They installed the software on an older computer where the installer does work, recorded every single thing the installer did, and then copied those exact steps onto the new computer. Like rebuilding a Lego set by watching someone else put it together. Here's how they pulled it off, step by step. Check the problem. They used a tool called SigCheck to figure out that the installer was 16-bit, way too old for a modern 64-bit computer. It's like checking the plug on an appliance to see if it fits your outlet. It didn't. Record everything. On an older computer, a 32-bit system, where the installer could run, they used Process Monitor, Procmon. This tool is like a video camera that records every move the computer makes. While the installer set up the software, Procmon tracked every file it created and every setting it changed in the computer's instruction manual, called the registry. Focus on the key stuff. After recording, they told Procmon to show only the successful, right actions. Basically, the moments where the installer actually added or changed something. It's like editing a long video to keep just the important scenes. Save the plan. They save this filtered list as an XML file, which is like organizing all the recorded steps in a neat, labeled folders that a computer can easily read. Make a to-do list. Using PowerShell, a tool that acts like a robot following instructions, they wrote a script to look through the XML file and make two lists. All the files the installer created, like game pieces. All the settings it changed in the registry, like instructions for where the pieces go. Copy it over. They wrote another script to take those files and settings and put them in the right places on the new 64-bit computer. It's like following a recipe to recreate the exact same dish someone else made. And guess what? It worked. The software ended up installed on the new computer without ever running the original installer. In this case, they found 1,319 files to copy and 1,790 registry changes to make. Pretty detailed work. It's a bit like watching a friend build a puzzle, noting every piece they place, and then building your own identical puzzle without the box instructions. This trick isn't just for old software. It could also help. Keep a record of what software does to your computer, useful for security or rules. Make new installers for old programs. Figure out why an installation isn't working. It's a brilliant example of using tools creatively to solve a tricky problem, like getting that old game running on your new laptop after all.
So this seems to be good. Here we can see, for example, this is the Procmon. He's filtering out this old software, and what it's doing exactly is he's filtering operation of interest, create file, write file, rename, all of these operations, and they should be successful. Okay, filter for operations of interest. All of these are the entries that he needs to see, or the software is doing to the system, and you should see the success operations only. Okay, and then after, and export that to an XML file, and then use the PowerShell to process, or to see the setting, or to see the data in this XML file. Okay, and then they will do a script to uh, do a couple of things. Okay, for example, maybe to put some registry keys and copy some files. So for example, here is the script. A couple of reg files need to be imported, a couple of files need to be moved to C partition, and maybe, for example, creating folders, for example, in certain locations. So all of these are what the script is doing. Okay, so very simple and very easy. Let's go to ChatGPT and see its explanation, which will be the last in our uh, video with Godwill. So let's see again the explanation. So here you go, this is it, and try to read it out loudly.
Problem: a company owns some old business programs. Turning a vintage installer into a modern one. The story in plain English. Problem: a company owns some old business programs. The setup files were 16-bit, designed for Windows 95 days. The actual programs they installed were 32-bit, which can run on modern 64-bit Windows. Catch: 22. 64-bit Windows won't even launch a 16-bit installer. Key insight: if we can't run the installer on a new PC, let's run it on an old 32-bit PC, watch everything it does, and then replay those same changes on the 64-bit PC. Think of it as recording a recipe step by step, then cooking it in a different kitchen. Tools and technique: app install recorder. Step: what they did. Why it matters. A. Confirm the installer is 16-bit. Ran sigcheck shows machine type 16-bit. Proves why it fails on 64-bit. B. Record the install. On a 32-bit machine, started process monitor procmon captured every file/registry right while running the installer. Creates a full change log. C. filter and save as XML. Kept only successful writes, exported to XML. XML keeps rich, structured data for scripting. D. Parse with PowerShell. Script read the XML, collected 319 new files plus 790 registry edits. Generates 2 clean lists, what to copy and what to add to registry. E. Recreate on 64-bit Windows. Second script copies files to the same folders and adds the registry keys. Voila! Program runs, even though the original installer never did. Why this is cool? No hacking the old software, just replaying its footsteps. Reusable trick for documenting installs for audits, fixing broken installers, or migrating ancient line of business apps. Quick glossary.
So as we can see here, very, very good explanation. And actually, this seems to be very, very good cases by Mr. Mark Rosenbench, okay, the creator of the tools. I think we have about 3 cases left. So with God will, in the upcoming video, we continue the 3 cases of this video informative to you all. And thank you all for viewing. Thank you so much.